Today I am discussing on escape velocity. This is a part of class 11. This is very important topic not only for board exam but also for any type of competitive exam. So first we have to know what is the escape velocity. Escape velocity is the velocity by which a body must be projected vertically upward to overcome the gravitational pull of the earth. This is the definition of escape velocity. So this is, first we have to write down this definition. So it is defined as the minimum velocity. It is defined as the minimum velocity by which a body must be projected vertically upward in order to that it may escape the gravitational pull of the earth. It is denoted by VE. V means that is escape velocity. Let the earth has mass m and radius r. Let us consider a point P. Let us consider a point P from the center of the earth at a distance x. So let us consider a point P from center, that is distance between P to O, that is x. So the force of attraction between the body and earth is, that is F equal to G mm by x square. So I have written G, that is gravitational constant, for small displacement dx, the work done is dw, that is dw equal to f into dx, that is this is the value of dw. Now so dw equal to g mm dx by x square. So we integrate when work done, that is 0, that is we can write that is r, that is w, that is infinity. So this is w, so gmm minus 1 by x, that is r to infinity, minus gmm 1 by x r to infinity. So we write that is w equal to minus gmm, so 1 by x r to infinity, so minus gmm 1 by infinity minus 1 by r, so minus gmm, that is 0 minus 1 by r, so plus gmm by r. So this is the value of w, so we can write that is gmm by r. So let escape velocity, that is ve. So when a body of mass m is projected upwards with velocity ve, that is kinetic energy, you can write half m v square. So this is equation number 1. So this is equation number 2. So from 1 and 2, so we get that is half m v square, that is gmm by r. So v equal to root over 2 gm by r. So this gives, so you can write this gives the required escape velocity in terms of g, m and r. So this is the required escape velocity. We know that is g equal to gm by r square. So gm equal to, in right, that is gr square. So we can write that is ve equal to root over 2 gm by r. So 2 gr square by r, that is v equal to root over 2gr. So this is another expression for escape velocity. Escape velocity in terms of g and r. So we get another format. So we know that is m, that is 4/3 pi r cube into rho. Rho is that is average density. Average density of earth. So VE 2g 4/3 pi r cube into rho. So we can write that is r, that is 8 pi 0/3. So this is another format of escape velocity. Now, so this is another format of escape velocity. So that is, we can write v equal root over 2gr. So 2 into 9.8, that is r. So we can write 11.2, that is km per second. This is the escape velocity. So this is the escape velocity. So a body, so we can write a body projected upwards, with a velocity 11.2 km per second from the surface of earth will escape the earth gravitational pull. So a body projected upwards with velocity 11.2, that is km per second from the surface of earth will escape the earth gravitational pull. One thing we have to remember, that is escape velocity for the sun, is very large, that is VE, that is sun, we can write 1616 km per second, and for moon for moon, that is, we can write 2.4 km per second. For this reason, all gases, that is lighter gases, all gases have escaped. All gases has escaped from the moon. There is no atmosphere around it. So escape velocity for moon very small, that is 2.4, that is km per second. For the reason there is no atmosphere around the moon. So we have written 3 equations, that is V equal to √2 gm by r. Second, that is V equal to that is √2 gr, and third, that is V equal to r √8 pi by 3 0. So this equation says that this is independent of mass. So these equations reveals that the escape velocity is independent of the mass of the body. So these 3 equations reveals that the escape velocity independent of mass of the body, that is m, small m. So today's class has been end of. I think this concept is very helpful for all students. Thank you all my dear students. Please watch all the videos and like, share and subscribe. Thank you.